但是这样多好啊！非周末周六。哎呀，我还说星期六怕下雨，那还50%降雨。
Okay.
下雨了就下雨了。那你最好把大伞拿。你最好拿两个。
Okay. Oh my God, that's I thought you. That's I thought you. I thought. I have a convenience. I will come for TikTok. Tesla. Can you hear me?
Yeah, hi, Jaden. I can hear you okay. Hi Jaden, hi Vivian, hi Ethan.
Can you turn down your sound? I want to hear it.
Yes. Yeah, let's just give other folks 1 more minute and then we can get started. Thanks for joining. Yeah, let me send a message in the group chat and I'll be back. Maybe people forget about the meeting today. We'll see if the reminder helps. Okay, guys, let's get started. Good evening, everyone. Today, we're gonna talk about how to make reusable programs. Can someone give me an example how you make things reusable in your life? Jaden?
Reusing trash.
Exactly. You recycle something and then you can reuse it, right? Anyone else? How about we make something and we use it again and again? What is an example of that? Ethan?
Like, if you buy something really useful, like for example, a car, you can drive it like every day without like buying a new one, unless you like crash or something.
Exactly. Exactly. Very good answer. Jack, what we're doing now is before we talk about today's topic, reusable program, we want to share just by each one of us what are the things that we have been reusing in our life, right? Jaden mentioned some of the recycled stuff you can reuse, like a container or a bottle. Ethan said if you buy a car, you can always reuse it instead of renting a car everywhere, right? Jack, you have something to share as well?
This might be a little strange, but a house.
A house, yes, exactly. Yeah, that's a very good example. And some of you may have been attending summer camps, right? Ethan's brother Aaron was building some really cool jars during the summer camp. It's an artwork. It's called Small Hands, Big Art. And when you create a jar, it can be reusable, right? You can put your school supplies in it. You can put your snacks in it. Whenever you find something that can fit in, you can reuse it, right? Okay, now let's pivot to the main topic we're going to discuss today, that is why we need to create reusable programs, or in other words, make our code reusable. Let me share with you an example, and then I'll be asking you some questions. Can you see this block code in Spike program?
Yes.
Okay. So this block code is the one we discussed on Tuesday, right? The first block is when you see a black line, you stop, right? And then the second one is when you try to follow the line, right? You do this type of coding so that it will do this zigzagging around the left and the right side of the line, right? Without losing track of it. In what way you might think about we need to make these two blocks reusable? Can you come up with an example that we may need to make these two blocks reusable? Jaden.
Copy and paste it.
Yeah, that is exactly right. That's how you make it reusable, right? But why do we need to make them reusable? Why we need to reuse them? Yeah, maybe Jack?
Maybe like if it only works one time, for example, it can only go one way, maybe you need it to go back.
Exactly. That is a very good explanation. Ethan, you have a different answer or same answer?
Like, to make it reusable, you could like save it. So next time you have it, the exact same copy.
Yeah, that's how you make it reusable, right? That's right. Yeah, let's focus on why we need to make it reusable. Jack said if you travel on the black line, you go forward, right? And then you also need to return to your base. You go backward. Then need to use the same program twice. That's exactly right. Jaden, you have something else to add?
I was thinking if you are doing like two things and the other thing needs the same code as this, you can just copy and paste it again.
Exactly. That's a very good answer. And that is one of the main reasons we need to use a reusable program. Anything else? Like if a Jaden created a line tracing, line following code, right, and make it really robust. In other words, it's very stable, right? It never goes wrong. In any scenario, it follows a black line perfectly, no matter how wide the line is, how fading the color is, right? As long as you can tell it's a black line, it works. Then Jaden will give this program to Ethan or to Vivian or to Jack, right? And then they can immediately take it over, make it their own, and start using it without, spelling out each line of this block code once after another, right? Life saves time. That help us to do the teamwork more effectively or working better together as a team. Alrighty? Okay. So let me show you a video from the last year's challenge, and I want you to focus on two things. All right. So what are the different type of turns they use in this mission completion demo, and how you can figure out what are the different types of turns they have been using, and how you can make those turns, those movements, reusable. All right. So just focus on the two questions. What are different type of movements, turns, go straight and so on, and how can you make them reusable, right? Okay, let me start playing. If you don't hear the sound, it's completely fine, but I will try to turn up the volume so you can hear it. All right, that's the end of the video.
What number you got?
How does everyone feel?
Good.
Good? I think you will be doing just as well if we figure things out and working together as a team, right? So we're gonna learn some of the basics, and let's answer that question. Give it some thoughts. What are the different type of movements? How can you make them reusable? Based on what you have seen from the video. Do they say going straight? Yes?
I couldn't really hear it.
Yeah, it's just the background music, doesn't add much. Yeah, I will send the video to the chat. Your parent have access, so you can replay it if you want. Yeah. So what other movement do you see? Do you see turns? Jack, you have
There was turns.
Mm-hmm.
Definitely turns. There's
Yeah.
also some lifting and some contracting, I think. Definitely lifting though.
Yeah. So what do you call those lifting, contracting, pushing?
Motion.
Yes. They are motion of the attachments, right? So if you think about the robot as a car, you have a car base, right? And then you install different arms, different tools, railings, hands, right? Hooks on the car, and all those stuff are called attachments. Yes. So we will make some of the attachments move, right? And some of these movements can be repetitive. Like if you lift something, like if you push something, right? If you spin something, all of this can be repeated several times in completing different jobs. Is that right?
Yeah. Mm-hmm.
Jaden?
They also changes motors, the motors.
Well, can you elaborate? Can you share more? What motors?
Like sometimes the motor is like A plus E, which makes an E plus A.
Mm-hmm.
Different motors. We make it go different ways.
Exactly. Yeah, you can change the motor setup. You can change the wheels on the motors, right? So it can be configured differently to move in different ways. Once you configure the motors and the wheels, how they're gonna move, you're gonna make it reusable, right? Because that is the optimal setting. Optimal means in most of the scenarios, we're not gonna fail, right? We're gonna be successful. Even the table is not completely flat, there's a little bit of slope, right? Or the map is kind of not even or worn out a little bit, right? The program can still work. That is kind of the reliability or the stableness of the program we're trying to achieve, right? And that requires lots of testing of the program. And that is why after lots of testing, we want to make the code final and then share it with others to make it reusable, right? Okay, so I will be sharing some of the code and ask you to think about how to implement it and make it reusable. Before we pivot to that topic, I do want to ask you guys a prompting question, a little more based on the video we watched. All right. So as you can tell, all these attachment movements can be modularized or can be made into reusable program, right? For example, you can call a block called lift, right? It will lift the arm, right? Every time you need to lift the arm, you just call a lift and all the code in it will get executed. And there are lots of turns, right? You can make a left turn and right turn, different reusable programs. And you can probably also tell from the video that the robot went through different runs, right? A run is starting from the starting line and end at the finishing line, right? There are like two half circles on both ends of the table, right? The robot usually goes from one end to the other, or starting from one end and returning to the same end, right? That's the end to finish. So during that one run, the robot complete a task in a specific order. Who can tell me why do you need to complete task in a specific order? Any ideas? Is it confusing, this question?
It might be more efficient.
Exactly. Efficiency, right? Save time, less likely to.
They could just do it all at once. Build a mega robot, all of the attachments to do one task, do it in the lowest time.
Yeah. Once you are more efficient, you spend less time, right? Let me share this. Sorry, I think there's something. Why did I make some? Sorry, there's an echoing sound. Now it's gone. So, do you guys see my screen again? Yeah. Oh, you do? Okay, sounds good. Just want to make sure. So, for example, on this Mac from last year, you have different mission models. You start from the left bottom corner, right? You drive the robot to station 1, 2, 3, and try to finish as much as possible. For example, the mouse pointing, let's see. Let me draw some circles, right? I really want you guys to start thinking about how to solve problems, because by the end of the day, we're gonna solve these problems, right? So this is the home base, and this is the presumably 1, and that is 2, right? And that is 3, and that is 4, right? So how do you decide which to go to? One is how can you save trip, right? Going from 1 to 2, 2 to 3, 3 to 4 sounds like the shortest distance, right? If you're going to 3 and then go back to 2, then go back to 4, it's probably more travel, right? What is another consideration? For example, you can start with 1 and finish a job in 2, and then maybe the job will unblock you for the trip, right? And then you can keep going to 3, something like that. So if you can finish a job to unblock some issue for the next job, you probably want to finish it first. Jaden?
I just think to do a different order. Go do 3, 4, and then 1 and 2.
Well, why do you think that might be a better idea?
I
That
don't
is
think
good
it's a
question.
better idea. I'm just suggesting a different way.
Different way, yes. It depends on the situation, right? And sometimes you also need to think about the other side of the equation, right? So you see the equation like 1 plus 1 equals to 2, right? On one side, you have 1 plus 1. On the other side, you have 2. On one side, we have efficiency, time, shortest distance, get the most done in less amount of time, right? On the other side, what do we need to think about? What is a very important consideration besides efficiency? Let me give you a hint. What if, yes, I can travel very fast to each destination. But after I finish the first job, I bump into something, I got stuck. I cannot even finish the remaining jobs. What is that called? What is the thing that will create some likelihood of failure or present us likely some chance for failure? What is that called? Jaden?
Errors.
Errors. Errors is the result, right? What's causing the error?
Wrong codes. Like
Wrong code, yes. Yeah, Jack?
More like obstacles or something we didn't plan out.
I love it. Obstacles. So something we didn't plan out. That is the key. Remember what he said, okay? Something we did not plan out is also called a risk. So on one side of the equation, you have efficiency. On the other side, you have risk. You always want to balance the two. Something is highly efficient does not mean it's guaranteed to be successful because it's just too risky, right? Like I have a second one, 6 years old. He's very good at picking watermelon because I taught him how to choose the best watermelon. But if you ask him to pick the watermelon and throw it across the street into my car. It's probably very risky, right? Because he does not have the manpower to do it. Yeah, same for a robot. If you design a robot with a very lean arm and ask it to pick something really heavy, right? It can be very risky. The arm may break or the arm may malfunction, right? So those are the things we need to consider. How to design the simplest solution to solve the problem in the most reliable way, right? So it can be repeated. That is the goal we're trying to achieve, all right? That is just a side discussion I want to share about, some gaming strategy or problem-solving strategy, how to balance efficiency and the risk. Okay, let me switch back to my notes. Any other questions on this topic or anything else to add? Yeah, again, there's no single way to do things. I really want to encourage all of you to think out loud when working on a problem, right? Okay. And the second question I want to ask you guys to think about is, as you see from the video, right, the robot usually starts from one corner, which is required, and then return to the same corner. Start is a requirement, but return is not always a requirement. Some team finish one task and return. Some other team finish 2-3 tasks and then return. But the only thing they always do, right, is to return to the base. Why do you think the robot return to the base or the starting position area in between missions is a good idea? I already told you the answer. It's good to return to the base. Jack, Jaden, please go ahead. Yeah.
Okay. Sorry, Jaden. Okay. It could be good because for each different task, you could probably have a different attachment. So you have more diversity to choose from, and you don't have to attach. I mean, like, sure, you could attach 2 at once, but it would be better to just return to check and to figure out what to do next.
Mm-hmm. To switch attachments. Exactly. That's one of the main reasons we want to return to base, right? Very good. Any other reasons? For your previous 2 hands-on exercise, did you notice that for the same program, you set out a marker blocker, marker pieces exactly the same way, but every time the robot turned out to be moving a little differently. That is called drift. All right. So anytime the robot make turns, it can cause some uncertainty. For example, you call it turn 90 degree, and it may not always turn 90 degree because the power is low, because the table is not flat, right?
Airs. What about like airs? What?
Air, exactly, because there's a big fan, right, in the room that is causing friction, right, because of something else, whatever reason. So the more you travel, the further away you can be from your destination. What is that called? So you have error. Every time you make a move, there's always some error, right? And you make more moves, more error. What is that called? Does anyone know the term? Yeah, it's called error propagation. All right. So basically, what it means is the error adds up, right? So the more you travel, the more missions you complete, because of this drifting and the uncertainty and the difference in the movement every time you run it will add up. So the more you complete the mission down the pike will be more uncertain or more risky to complete. That is why when you complete a mission, or when we complete a mission or two, right, or a cluster missions, we return the robot to the base to reset it. The base has some lines, has an edge. If you push the robot against the edge, it's always in the same position, right? So that is a very good practice, so that we can always start at the same position to begin the mission. Does that make sense? Okay. All right, let me share my screen again, and then we're gonna walk you through the training module. And then we're gonna have some discussion. All right. So let me go back here. And this is the module we're gonna talk about today, called the My Code Out program. And let me just play this video real quick. Yeah. The prompt is, now we are working together as a team. Everyone will have the opportunity to build something, code something, right? Make the robot to do something. How can we make sure we involve everyone? How can we make sure we divide and conquer, right? Different people build different parts of it, code different parts of it, and everyone is done. We come together to build something bigger, right? By combining the results. This is the goal of this talk, right? To see how we can make our code reusable, how we can make our own program, so that we can really achieve this goal of having a team effort. Okay, so this is just a simple example of making a block called drive square, right? And we're gonna take a look at how we can practice building this code using the concept of my block. We'll just skip this part. Basically, it's very simple. You just create two markers, right? You can create your own marker if you don't like this one, which is completely fine. You just create a object for us to drive around. And then here's the sample code, right? What this sample code does is, first set up an initial parameter, right? How do you connect to your wheels? What's the initial speed? And what do you mean by one rotation, right? And then we have something interesting, right? It says move an arrow pointing up for 2 rotations. All right. And then for this part of the code, let me just blow it up a little bit more so you can see it. It's being nested underneath define forward. Who can tell me what is this red thing called define forward? Jaden?
This is where you make a block, and once you make a block, it'll show this, and then you define it, and then you grab this block from my blocks and then place it under something.
Exactly.
And then it'll do exactly what this says.
Yes, exactly. This is how you make a reusable block, right? So this is the example of my block. If you go to my block, you can see exactly forward is here, right? Forward is the name of the block, and that is what the block is gonna do when you call forward. And you can call forward anywhere within this same program, right? You can call it on a button click. You can call it on seeing a black line. You can call it on getting closer enough to an object or your mission model, right? You can do something else, right? But it will always do this thing, defined inside that block, and you don't have to repeat the code. That's really the benefit of having a my block code, right? Define it once and use it everywhere. Okay. What is this? Can anyone tell me what is the sticker you see on the screen? It says, this is my block that will make your driving base drive forward. Jack?
What it means is wherever this forward thing block is, when right button press, then the robot will move forward.
Mm-hmm. Yeah, this is what the explanation is. Yeah. Yeah. What is this thing called? This yellow sticker thing. Do you know what is called encoding? Jaden?
It's called a comment, probably.
Bravo.
Comment.
Yeah, comment. Comment.
Once you right click, this will show.
Exactly. Why do you need to write a comment?
So people know what this does.
Exactly. What this does. When Jaden, you write a code, right? How many lines of code do you want to write? As much as needed, right? As many as needed. If you say I want to write 100 lines of code, yeah, people will say, oh, sum up, you are so good, but why do you write? Why can't you write like 10 lines of code to get the same job done for 100 lines, right? So as many as needed. But once you write lots of code, right? Potentially we're gonna write lots of code for lots of my blocks. And when you share it with your team, right? Jaden write like 10 blocks and share with Jack. Jack will say, oh, I don't understand which one is the one I want to use, right? How does each one of these code executes, right? Is there any input and output, right? Is it helping the robot to move or helping the robot to do some actions? I don't know, right? This comment will tell all of us on the team, even though you are not the one building the code, how this code is supposed to work. That's very important, okay? So starting probably next week or in 2 weeks, we'll be all writing lots of code. Coach David and other mentors and coaches will be provide you some sample tutorial to run through. And I would like to have each one of you to write some code by yourself. You can write the exact same thing as a sample code to get something done, or you can tweak it your own. But after you write every piece of code, I want you to add a comment to explain what this code does. All right. So that is the future requirement when we start coding. We need to be very vigilant, right? Or like a very diligent in writing these comments or adding these comments. Yeah, Jaden, you have a question?
You're on iPad, how do you get a comment? Like,
If you right click on it, you can add a comment. If you are on iPad, you need to put the tool of your fingers on the code block. Yeah, that usually bring up Does anyone know what is this called? If you right click on something and bring out this menu, what is this menu called? Context menu. All right. So yeah, I'm teaching you something about computer. This is computer 101, but this is very interesting to learn as well. All right. So bring up the context menu and you will be see this option. Okay. So now let's see how we can create blocks of code to make different terms, right? As we said in the mission video we watched in the very beginning, there are so many different terms and we don't want to create the same code for each term, right? We just create one code and we can use for as many terms as possible, right? Okay, so let's see what are different terms that we are going to implement. Okay, so this is just a square term, all right? And this is a triangle term. This is a circle term, okay? And then let's try to define some of these terms together, okay? So for the remaining time, I will be the person entering the block, and I would like to have each one of you tell me where to go, right? Let's start with defining the first block. How do you want to call it? You want to call it a square? Yeah, okay. Let's make a square. So when you call this block, the robot will drive in a square. All right, so this is how you create a new my block. This is currently an empty block, nothing in it, right? And then we're gonna define the code so that we can repeat it every time by calling square, just like we did for forward. Okay, now it's time to do the pseudocoding. You guys still remember the pseudocode, right? What is pseudocode? Pseudocode is the way we describe a problem-solving process in plain English, right? If you want to drive the robot in a square, tell me what are the actions, what are the movements it needs to do? Jaden?
Use move forward for 2 rotations or the forward block, and then use rotate 90 degrees, and then do move and then put repeat for 3 or 4 times. Know how much?
Move forward. Yeah, move forward for 2 rotations and move right for 90 degrees, right?
And then you keep on repeating it until you have.
Use this one. Move right.
I think
you should move left.
You want to turn left or turn left?
Left.
Turn right. Yeah, turn left. Okay, that's fine. We can turn left. Boom, it's already left.
Rotating left. I thought it was rotating left.
Okay, so
it's like in the motors, probably.
Still okay.
Yeah, so it doesn't matter if you turn left or turn right, as long as you go in a square, we're good, right? Okay. Jack, you have something to add or you're done already?
I'm good.
Good. Okay. So yeah, Vivian and Ethan, do you think this is the right block to use? Move forward for 2 rotations, move left or right using this bearing for certain duration. Ethan is thinking. I couldn't tell Vivian.
Yeah, I think it might work.
It's
Might work?
okay.
Okay, yeah. Okay, yeah, this is exactly the right block to use. Yeah, both of you are right. All right, so let's talk about this. What does this tell you? Like, if I remove this steering thing, what does it mimic? Jaden.
I just have a question. Why did aren't you supposed to put move forward for 2 rotation and move straight, move right for 10 rotation under define square, not square?
Define square.
Like this right next to in program.
I used the wrong thing. Yeah, it should be define square. Square is when you call it. Yes, you're exactly right. Thank you for the catch. Yeah. See, he's listening. All right. That's very important. Good job. Jack, you have a comment?
Okay, about the steering wheel thing. It looks like a car.
Exactly.
And when you turn the steering wheel left, it points left.
Exactly. All right. So I want you to think about this. This is like a car. All right. You probably haven't been able to drive your parents' car, but you probably drive like what is it called? K-car or go-kart, right? You probably ride go-kart or some used park. You have drive some electric car or in your neighborhood, right? Everyone have used the steering wheel at some point in some shape or form, right? So think about this as the power you're gonna use to steer. All right. So if you want to steer all the way to the left, are you gonna use 100% of power or 1% of power? All the way to the left. Left is like the end of the left. Jaden.
100% power.
Exactly, because you want to reach to the end, right? So that it can go all the way to the left. So this left minus 100 is exactly that. 100 really means 100% of the power, not 100 degree. Because you see, if you think about it, right, left is actually 90 degree on your left, right? If your head is pointing up to 0 degree, then your left arm going parallel to the ground is actually 90 degree. But when you think about power, it's actually how you turn the steering wheel to go left, right? So if you want to go left 90 degree, you actually set it to 100, or in this case, minus 100. Same for turning right, right? If you want to go straight right, it's 100 right, okay? So this is the direction plus power. And then this second number is called duration, right? It can be defined in terms of how many rotations of the wheels. One rotation is one circumstance of the wheel, right? Or degrees or seconds. And normally rotation is the common one to use. All right. So once we define this square, it's pretty good, right? We can use it, right? When the right button is pressed, it will go forward and it will draw a square. The way you do it is just to drag this my block name square underneath that triggering event. All right. Very good. Any questions about this one? No? Okay. Let's talk about the second one. All right. So who can tell me if I want to driving a triangle, where should I go first?
我也录音了
Jack?
，12点50几。
You should probably go forward.
Yeah.
And then you turn. and then you turn that exact same degree again, and then you're back where you started.
Okay, you preceded me. Okay, I'm talking about how to define the block first, my block. So go to my block on the left, right? Is that what you're trying to say?
Yeah, you go to my block. I kind of misunderstood the question. You named the block name triangle.
Uh-huh. You click save.
You click
Yeah.
save. And then you have define triangle.
Yes.
All you need to do is just copy the define square code, just to modify it a little bit so that it does not turn over 90 degrees.
Okay. So before we do that, do you see a problem with the previous square? We only draw one line or one side. Jaden, is that what you're trying to say?
I'm saying that if you were supposed to define the triangle, you first do move forward for like 10 rotations and then turn something degrees. I don't really know how much degrees because it depends on what triangle it is. And then you do the same thing again. Again.
3 times. You do it 3 times, right? So in the last block, we need to add a repeat block, right? Is it gonna be forever? Or is it gonna be repeat a couple of times? Which one? For the square. Repeat, right? If you do it forever, it will draw lots of squares and never stop. But if you repeat this block of code 4 times, it will draw 4 lines to close it as a square, right? Jaden?
You put the repeat block in define square, not define triangle.
Yeah, so we also need one for define triangle, right?
So let's move forward for 10 rotations and then like move left like about 80 degrees. Move left like 20, like I don't know how much degrees, it just depends on what triangle it is.
As long as it's not over 90 degrees.
Yeah. So if you move left to 100, that's 90 degree. You want to do 90 degree? Probably not, right? What's the degree? Let's talk about degree. What's the degree for a perfect triangle? You know that number?
180.
180 is, that's the total degree for a triangle.
Yeah.
So you want to create an angle of 60 degree, right?
Yeah, 180 divided by 3.
Exactly. Very good. You guys are doing pretty good, on math. That helps a lot, all right? So you want to create a 60-degree angle, and we don't know what or how the power 100 translate to 60 degree. We know power 100 is translated to what degree? 90 degree, right? So 60 degrees is kind of 2/3 of the 90 degree. So if you kind of eyeball it or just estimate it, right? So yeah, you can probably start around like 50, right? And tune it. So nobody knows what's the perfect number. I don't know, all right? You probably don't know either. But what we can do is to try these different numbers and then to figure out which is the right number for our wheels, for a robot, and so on. Okay, so there's no perfect answer here. Yeah, I would start with -50, maybe this rotation, like 1 rotation, something like that to begin with. All right, so this is exactly right. This is basically the right code. We just need to test it. Does that make sense? Okay, so we define the second my block called triangle. Once you have that, we can actually call the triangle in the main program or under the triggering event. Can anyone tell me how to call this triangle function or triangle block? Jack?
if I'm not wrong, you place when something button clicked, forward, then triangle.
Mm-hmm. Yeah, you drag the triangle my block underneath the list of my blocks on the left-hand side panel, right? And then you put it into place you want it to be executed. Okay, very good. See, we're almost done for this exercise. Last one, I will just do it very quickly with you. It's called draw a circle, right? So this is the starting of the block. What is the one code we need to put in here? There's no travel a straight line. So there's no such thing like go straight for X amount, right? But it still have movement. So we know we need movement. Just go to movement and then find this magic code, right? We'll be using this piece of movement code again and again, right? This is my favorite code because it has two things, turn and duration, the distance. And it can control both wheels, all right? Can anyone tell me what is the setting here for the two blanks? So if you don't know how to make a magic number, start with what? Jaden?
30?
Yeah, you can start with 30 or start with 50 because 50 is the average. Have you done there's a guess game? Like if I'm thinking about a number and you can tell me what's the number in my mind, I can only tell you it's a bigger or smaller. Have you played that game with your friends or parents?
I actually made that game on Scratch.
Yeah, exactly. So that is the game we're playing, okay? So why this skill is such an important skill? Because it helps you to quickly arrive at an answer, all right? So if you know how to do this search, it's called actually binary search. Once you get more advanced, you will do lots of like searching algorithm to find something. Like if you are putting a keyword in Google and Google will give you exact web page you need, it's not a very easy problem, right? Ethan, how many web pages does Google have?
A lot.
It's called a Google, okay? Google is actually a quantity, right? It means a huge number. So if you can Google what a Google means, it's actually a quantity. So yeah, so this way will help you to search a space of possible values and narrow down quickly to the best value. So we can start with 50, right? And once we get more hands-on on it, we understand, maybe 50 is not always the right answer. Maybe we should start with 30. Then that's what we learned, right? But it's hindsight. At this point, we don't know. So you can start with 50, and then you can either turn left or right. Doesn't really matter which direction you go to draw a circle, right? And then you can start with something like 2 rotations or 3 rotations. Okay? And then what you're gonna do is just to test it, right? For our map, for our mission model, probably we're gonna operate in a very confined or defined area. We cannot draw big circles. We probably need to draw a small circle, right? Yeah, we need to turn around to get something done. That's why we need to have this circular motion, right? So I hope all this is connecting together for you. And yeah, so this is pretty much it. Once you have the circle, how do you put in the last puzzle to call it in the main program? Anyone? Just go to my block, right? And then draw the circle into wherever you want to call it. Okay, done. This is how you build a program for yourself and make it reusable. Again, we are working together as a team. Each person will be developing some programs, and you will be sharing your program with others and vice versa. So once you are done developing your program, what you can do before you can share with others is go to File and save this piece of code. It's actually a code project onto your computer. And then we'll be using Google Drive, we'll be using Zoom file sharing to share the code file with each other. That way, we can just load other people's file into our SPI program IDE or independent development environment to use the code developed by others. Does it make sense? Okay. Sounds good. That concludes today's training camp. I hope you all learned something. Next class, we'll be reviewing some of these topics. If you have any questions, feel free to bring them over. Otherwise, we'll be pretty much done for our 101, and we will get into the fun part from August the 5th, when our mission thing will be reviewed. All right, so stay tuned. See you in the next class. Have a good rest of your evening.
Bye.
Bye-bye.